that these animals have, one of them being the big furry coats. That you guys, what did you do with mice?
We made woolly mice.
See if you can find that.
The only like unintended consequences was they were cute as fuck. Like people have lost their minds, right? Like I was on the phone recently with a moderately aggressive journalist, and it was going quite poorly, as some calls go.
Moderately aggressive? They were being aggressive in what way? Like, why are you doing this?
Some people, yeah, everyone likes
Look
to
how
fight it.
cute.
Yeah. So
my daughter actually found this online and wants one.
Yeah, so we get that a lot from
She wants
from
a woolly
kids.
mouse.
So every week, I don't have my laptop. I should have
Look
brought it
how
in here.
cute.
But every week.
Oh my God, they're adorable.
So these woolly mice aren't just adorable. We basically said, look, what are the core genes that drive the hair phenotype or physical attribute of a mammoth, from an aged elephant to a mammoth? And then because we want to do this in the most ethical way as possible, there's about 200 million years of genetic divergence between mice and elephants. We didn't just want to ram mammoth DNA in there and see what happens. So we looked for the mouse equivalent, right? So we look for, like, all of us have similar genes. And so we can try to look for those genes and then edit those genes with the data we got from the mammoth, so that we're then not just putting random genes in there that could either hurt the animal or kill them, right? Or they may not even be compatible with life, right? So we try to be really, really thoughtful about it. And the woolly mice went like, it went insane. There's people that are like making t-shirts. There's a meme coin. And so we made 36 mice. They're all healthy. There's 36 mice that we made. And what was crazy about it is we're excited about it because it shows that the end-to-end process of taking data from an ancient DNA, comparing it to a living animal, making those changes, doing it with 100% efficiency. And that's really important and really hard. So we did it with 100% efficiency. Yeah, that's the
difference.
Well, so the
one
mouse,
of them, if it was in a trap, you'd be so sad.
yeah,
Like
exactly.
the little guy on the left, if he was in a trap, I'd be like, oh, look what we killed. Isn't that funny? Just a little bit of fur.
Yeah.
Makes you love them.
And that's the color that we think most mammoths were. So,
Really? They were like a blonde.
They were like a golden brown color, right? Because when we pull them out of the permafrost, they've been sitting in mud for quite some time. But if you see very fresh mammoths, like from Siberia and whatnot, like in Yakuts and other places in northern Siberia, that they actually have pretty well preserved mammoths, they actually have kind of a dirty blonde meets gold meets brown fur.
Wow.
And so we did that, and now there's people that are making T-shirts that aren't us, and pillows that are like legalized woolly mice. I'm like, they're not illegal. And then there's a meme account for the guy that did the CRISPR babies, that went in trouble for making edited babies in China. Yeah. A meme account.
Oh wow. So that's mammoth fur.
Yeah.
Wow.
A meme account though actually said on X that these are a bioweapon. And that Colossal is made of bio. So the weirdness of the woolly mouse went crazy viral. What we were trying to show is that we used our multiplex editing tools, meaning that we edited all of those genes at the same time. Most people edit one gene, let that mouse live. From the second lineage, they'll do one more gene, let that mouse live, and then they'll stack those edits over multiple generations. We've developed a system so that we can deliver all of those edits at one time, all over the genome, get exactly what we want. And then we have this what's called monoclonal screening, where we're screening the cells at the end, sequencing all of the cells, which is expensive and sounds like overkill. But then we know that none of them have unintended consequences or off-target effects in the genome, so that we know the mice that we then do cloning with, we know that they'll be healthy. And so we try to spend a lot of time, on that, because we're certified by American Humane Society. It's the oldest humane organization in the world. And if you've seen the film, that's like no animals were harmed in the making of this film. That's those guys.
Right.
So we've ended up. So we really care about kind of not just the de-extinction efforts, the genome engineering efforts, but ensuring that the animals are healthy when they come out. And so the woolly mouse was a really interesting proof of concept. It shows that the edits that we are working on are working right, and we're getting exactly what we predicted.
Is there any plans to sell those?
No, everyone keeps asking us that. But you know what? Museums actually are now calling us saying, and zoos are calling us saying, can we display the woolly mice? They're like, it'll drive so much value. It'll teach people about, genetics and whatnot. So, it's not our business model to sell our animals or to sell, woolly mice, but it's kind of gone crazy.
Is it dangerous though to leave these mice in the hands of someone, even at a zoo, who decides I want more of these?
Yeah, if we ever put them I think more likely we'd put them in a museum that needs to be free, like the Smithsonian or something like that, from an education perspective, versus something that's more attraction based. I think we do it more in the case of a museum.
Do you plan on keeping this batch alive?
Yeah, they're going to live out their normal lives, but
you're not going to make new ones.
We may make new ones.
What if they breed?
These won't. They're all separated. They're all separated by sex. So we're not gonna have like a Jurassic Park moment where they change. They're all separated by sex. But if Jamie finds a picture of their habitats, they actually live. They live a couple years, but they don't live like traditional lab mice that live in like a small little cage and all on top of each other. They actually live in pretty sweet digs that we made for them. That are all like we spared no expense.
Cool little house.
Yeah, and they're big, and we put fun stuff in them to play with, like this. And what's been crazy is we only named 2 of them. And we named them Chip and Dale because we people were asking what the names were, and I was like, Chip is the only thing that I could think of at the moment. And now even on X, people are like, we need pictures of Chip. Where is Chip? We've only seen pictures of Dale. And there's like these incredible internet sleuths that are like, that's not Chip, that's Dale. We need a picture of Chip.
Yeah, you can't get involved.
Yeah, so we've just
don't get involved with those people.
We've not leaned in. Yeah,
you cannot.
We're excited. They're excited, but we just can't. We're busy.
So this is a new thing. The woolly mouse is a new thing. Mm-hmm. Is there any talk about doing other kind of new things?
So it's more of a proof of technology. I think that the mouse model, because it's a 20-day gestation versus 22 months in elephants, it's a great way to test phenotypes. Because with a mammoth, you have 3 ways to test if you got the edits right. 1, you can do molecular tests. You can do DNA sequencing to see if it worked. 2, I guess there's 4. 2, you could grow a mammoth and see if it looks like it, but that's a lot of work in 22 months, like a lot of gestational time, a lot of money. I think there's a lot of risk in that. The third, and this is a little weird, we created what's called induced pluripotent stem cells. So we created cells that you can then turn into any type of tissue. So we actually do have mammoth hair follicles growing in a lab. So we have hair growing in petri dishes in the lab, which is pretty cool. If you come see the lab, you'll get the whole Willy Wonka tour of it, which is pretty cool. And then the fourth way is mice, right? Because it's like if we can then engineer them into mice, we can see immediately within 20 days if the edits were working, if there were any unintended consequences that would be detrimental to the animal.
Wow.
So we'll probably make more iterations of the woolly mice. The thylacines' closest living relative is the fat-tailed Dunnart, which is a mouse-sized marsupial, and it actually gestates in 13 and a half days versus 20 days. So there's no reason to do it in mice when you can do it immediately in the model species.
Wow.
Yeah.